A curved crucible wall changes how heat enters a high-temperature load. In furnace and reactor work, geometry affects contact, heat flow, stress distribution, and handling during repeated cycles. The conical Zirconia Crucible family covers compact laboratory vessels and larger furnace vessels. The custom range includes 5 to 500 milliliter volumes, top diameters from 25 to 100 millimeters, and wall thickness from 1.3 to 5.5 millimeters, allowing engineers to match charge volume and chamber clearance. The stabilized zirconia composition uses zirconium oxide at 92% or higher. Apparent porosity is specified at 0.5% or lower, and bulk density is 4.5 grams per cubic centimeter or higher, so the ceramic body can limit gas pathways and molten material penetration. For high-temperature operation, the crucible is specified for service up to 2200 degrees Celsius. Thermal cycling still needs discipline. Use controlled heating and cooling, especially 5 degrees Celsius per minute or lower below 1200 degrees Celsius and 4 degrees Celsius per minute or lower above 1200 degrees Celsius. The application focus shown here is induction furnace heating with a semi-cylindrical coil field. A curved wall can follow the coil profile more closely than a rectangular vessel, helping smooth wall heat flux and reduce hot spot formation. Low thermal conductivity, listed at 2.5 to 3.0 watts per meter Kelvin at 1000 degrees Celsius, limits lateral heat loss while the dense wall maintains a steadier thermal response.